Okay, 2017 higher level question 7. We have a sketch here of a roof, so it's going to be something to do with any eaves detail. The slated roof of a new house is constructed using prefabricated truss rafters and has a pitch of 45 degrees. The internal span of the house is 4 meters. The roof is supported on external walls of timber frame construction, having a rendered concrete block external leaf. Both the roof and the walls are highly insulated. To a scale of 1:10, draw a vertical section through the roof structure, showing typical construction details from a 400 millimeters below the ceiling up to ridge level and include both external walls. Show the typical design detailing at one of the eaves and include battens, membranes, and 4 courses of slate at the eaves. Label the components. Part B, on your drawing, show the typical dimensions of 3 roof members. Okay, so basically what we have there is timber frame wall with a prefabricated truss roof, and we have to show the full thing. We have to show this side, we have to show that side, and we have to show the full truss and the details there. It says do the detailing at one of the eaves, so put the battens and slates and that on one of the eaves, and the other, and the battens and the slates on one eaves, and doesn't need to be done on the other eaves. We'll underline some of the key words. So the slated roof, so it's slated, of a new house is constructed using prefabricated trussed rafters and has a pitch of 45 degrees. The internal span of the house is 4 meters. We need that because we're doing both sides, so we know from here to here is 4 meters. And the roof is supported on external walls of timber frame construction. It does not say how big the timber frame is, so you go back to your standard timber frame of 150 millimeters, having a rendered concrete block external leaf. Both the roof and the walls are highly insulated. To a scale of 1:10, draw a vertical section through the roof structure. Show typical construction details from a level 400 millimeters below the ceiling up to ridge level. So we're going 400 mil below here, all the way up to ridge. That's the ridge there. Show the include both external walls. That's very important. We must do both sides of this roof. Often we do this and we only have to do half of it, but this particular detail wants both walls. Show the typical design detailing at one of the eaves and include battens, membranes, and 4 courses of the slates at that eaves. Label the components. Alright, so essentially we have both walls, a full truss, and the detailing on one of the sides regarding slates. One thing which we've spoken about before, when it comes to a prefabricated truss roof, that is, the trusses are pre-made in the factory and they're lifted in by a crane and they rest in. As we when we usually draw this, the rafters, for example, if say that's your wall, all right, say it's a concrete wall, and you have your wall plate on top of that, we always have to make sure that the rafter cuts through there. The bird's mouth joint there, it's cutting in, it's nailed into the wall plate. When it comes to a prefabricated truss roof, especially with timber frame construction, those trusses are not cut into the wall. There's a wall plate on there on top of it, and the trusses just rest on that. Okay, so the trusses simply just rest down on the wall here, and they're cut into the wall plate there. So they rest on the wall plate here, they cut into the wall plate there. Just a photograph of that to help it a bit more understandable. That's a photograph there of some timber frame trusses being put into place. You can see there, that's the timber frame panel. They have yet to build the external wall, and that you can see the timber frame truss is just resting on that wall plate, and they're fixed to place with what's called truss clips. They're like little galvanized steel structures. Okay, so we'll start doing that. It's scale 1:10. It's going to be quite big because we're showing 2 walls and we're showing a full truss, so we've got to make sure that we start low and to the left as always. Alright, so we'll start on one side. Timber frame wall. I'll come here, there's the bottom left hand side corner of my page. I'm going to come in a small bit just to make sure we've got room for soffit and fascia and so on, and we're going to draw the timber frame panel. Standard size for a timber frame panel is 150, so it does not state how big it needs to be, so then you make sure it's just 150. It says to go 400 millimeters below the roof detail, so make sure you have 400 millimeters there. Alright, there's my 150 panel. I'll put my insulation into that panel. There's no mention of a service cavity, so we're simply going to put a plasterboard here, but I might just put the that's the head plate on top of the panel, and that's the wall plate on top of the panel. So that's like the top rail, the head plate's like the top rail of the panel, and then they fix the wall plate to that so that you can rest it on. Plasterboard is fixed to the side of that. Your OSB board is fixed to there. Alright, and as always, we have air tightness membrane just inside the plasterboard, and your breather membrane is on the outside of the OSB wood. And as we said, there's no mention of a service cavity on this. Sometimes in the more modern houses there's a service cavity, but there's no mention of it, so we'll leave it out. Okay, now 45 degrees, quite a steep pitch. I would reckon our external wall needs to be a little bit lower, so what I would do next is I would draw my 45 degree pitch. So it's going to be up like that, right? That now allows me to know how high to go up with the wall. Again, we don't need to overthink that, because oftentimes I just cut bits out of the wall. But look, if it's going quite well below it, we'll go down, we'll go across our 50mm for a cavity, then across our 100, and just go a little bit lower with that external wall. It just makes it easier to understand. That's what they would generally do. They would put that in place and they build the wall up to the top of that. Alright, you might get 1 or 2 blocks in there as well. Now, next you can go on, maybe if you want, to the other wall. The internal span of this house is 4 meters. So that means from the inside of this wall to the inside of the other wall must be 4 meters. So that's 4,000 millimeters. You scale that down. It's going to be quite big. It's going to use a lot of your page. So I'm going to just get that done in there now as well. So measure across your 4 meters and draw in the same thing. There's the head plate. Get the wall plate on there. Your insulation. Your plasterboard on the inside, your OSB wood on the outside, your breather membrane goes on the outside of that, your air tightness membrane goes on the inside of the plasterboard. Go up at your 45 degrees there, and then go across 50 for your cavity and draw in your external block leaf. Okay, there's our 2 walls done as asked in the question. I'll extend up my rafter now, 45 degrees, 45 degrees, both sides. We'll go back over to this side here. The size of a rafter, standard size is 150, so we'll go out 150 and we'll go 45 degrees there as well. And the same over here, 150 millimeters, and go down at your 45 degrees there. Now these are prefabricated truss rafters. We've done this before. The joist part of the the truss comes across here. Again, 150 millimeters. All right. At that point, we'll do our little ties in it. So with your standard Fink truss rafter, come up again. Make a judgment yourself on the size. Come up roughly about that much. Go at an angle 60 degrees will work probably best. 150 millimeters. Do this all lightly first of all. That needs to work its way up to the top. So go up like that. You can use your set squares, use your judgment, and what we'll have then is those little structural members of the truss. So they're all 150 millimeters thick. The position of those and the angle of those, there's a little bit of room for variation, but this must go up to the center like that. They must be jointed in like that, and you know, make your judgment on that angle there. Same on the other side. So whatever measurement you use here, you must do the same on the other side. So just make sure that they mirror each other properly. That's going to come down here. A little bit of practice in drawing those up, and you have the position of all those. Now again, those members are all held together by nail plates, which I've shown before. They're just steel plates with kind of that are fixed into those. These are all made on machines, by the way, in the timber frame factory. All right, they're just shaded in grey. Size of those, don't overthink the size of those. Just get something in drawn like that. There's a nail plate on both sides, which keeps the whole thing nice and secure. And there's also going to be a nail plate here, so rub out any of the lines that you need to get rid of. There, and there'll also be a nail plate over here. Okay, now on one of the sides it says, can we do your detailing at the eaves? So again, make your judgment on where the fascia is going to go. 25mm fascia, slightly above there. Slightly below as well. 12mm soffit, draw your vent into place. And then your 4 courses of slates. So it says 4 courses of slates. So get your tilting fillet in, and we're going to go 350mm. Draw a batten. The batten is 50 by 35. From the front of that batten, measure up your next one, 350mm. From the front of that batten, go up to your next one, 350mm, and we'll do an extra one as well just to be sure we cover what's been asked. Okay, and then between here and here we draw a batten in the middle, and we'll draw our first slate that size, our second slate that size, and then your first full slate will go along there, and then your next full slate will come along like this, and your next full slate will come like that. Again, we've spoken several times about neatness on that, and you'll see the neatness required on the solution. Okay, 1, 2, 3, 4 courses of slates covered. If you want to do an extra 1 or 2, that'll be fine. We have pretty much everything covered there. A couple of small things probably forgotten about. Get your cavity closer in there. Oh, it mentions that it's highly insulated, so you want to get your insulation between each of the joists. If you want to highly insulate it again, you want to get your insulation ease ventilator. We'll get along there, 30mm by 600 or 700, and then you want to have plenty of insulation coming along down along there. That'll come down in, and maybe you could put a second layer of insulation on top of that because it says it's highly insulated. Okay, so just make sure you have plenty of insulation along the whole thing. It says make sure you add the part B. It says drawing show typical dimensions of 3 roof members. So you could mention here that we've got a 150 by 50mm joist. You've got a 150 by 50mm rafter. And you could maybe label 50 by 35mm battens. You could do 25mm fascia, or label your soffit as well. They're all roof members also. Okay, and again, get your 12 or 13 or 14 labels done as well with sizes. Now the full solution, we can see here now. So first of all, you can see it's quite big on the page because of the 45-degree angle. There is the wall on the left, detailing there. You can see the slates done nice and neatly. Over to the other side, I didn't do the slates on the other side, but I did include the fascia and soffit and all of that in the eaves detail. And overall, the whole thing there. A couple of measurements. There's the joist measurement. There's the rafter measurement, the batten measurement, slates, you know, they can count. Fascia and soffit, they can count the measurements too. Alright, so have a look at that and have a go at that question.